Hey everyone, exam review video for Algebra 2. Now it's going to be a little funky here because if you're watching this in the future, that is during a regular exam week, then stat stuff is not included on there. You'll have to get a separate video for that, which is upcoming in the future. Everything else, seniors, you did all this stuff except for the stats. And so everything, this is for the seniors first and then the regular class last, which is why you will have stats at the end. And then for my Algebra 2 block class, that's third and fourth hour, at least in 2025 it is, but I don't know when it is. In the future. See, in the future, that's how people talk. Um, Algebra 2 block class, there's also one problem that you don't have to worry about. You'll see it when you get to it. Just skip it and move on. Fast forward to the problems that pertain to you. All right, too much talking, not enough mathin'. Let's get to the mathin'. If you're a senior and you've benefited from these videos, stop by, give me a high five, and get a congratulations. A free high five from me. There's the share button. Free high five from me. Tell me what's going on next year. Hopefully everything's going sweet. Why is that? All right, we are here. And we are good to. Now we're good to go. All right. Just in case you thought that I'd probably have this pen and the sharing the videos figured out in the future, but I don't yet. So here we are. Okay, slow start, but the rest won't be so slow. All right, growth factor over the 30-month period, we had to have our starting value over, sorry, new divided by old. So I try to preach to people, new divided by old, whether you're growing or shrinking, it's going to be new divided by old. So your new cost divided by the old, that gives us a growth period of 2 a growth factor of 2.82 over the 30-month period. Now, if you want to know what that 30-month growth period is by each month, you just take that 2.82 or the fraction itself and take it to the power of 1/30th because we want one of those months out of the 30. Okay, so there's two ways you could write this. You can either say, hey, I started at 1170. Oh, I didn't give you the answer there. Okay, so do that. Don't just leave it how I did and get the number, which would be a growth rate of 0.035, 3.5% per month. So if you use that monthly rate, that's all good. Just make sure that your exponent then is just months. If you don't use monthly rate, if you use that first growth factor that you found, 2.82, you can do that, but just realize that you need to take the amount of months that happened and divide it by 30 in your exponent. Okay, so either of those would be acceptable answers. Just realizing that letter D is not on your review, is not on my review from last year. It is on yours. Letter D, where it asks for what does f of 5 mean? Okay, it means what is the price, the price of the stock after 5 months. Now, you could have also been specific and said 5 months from then would be December 2018. If you went above and beyond and actually calculated that, it was $1,389.59. Question doesn't necessarily ask for that, but if you did it, figure that out. All right, growth factor over the 6-year period on the next one. Again, our new divided by our old. So now our growth factor, we've kind of got, quotations around there because we're not growing, right? The value of this is going down. Take our original price in the denominator, the new price here, and we've actually found out that we are now worth 40% of what we were. Okay, so that car that over 6 years is now worth 40%. Well, what happened each year? Well, if you take that 0.4, you take it to the power of 1/6, you found out, well, it was actually worth 85.8% of what it was the previous year, year after year after year. Okay, so again, we have two instances or two ways that you can write this. Either way, you're going to have the same starting value. Your growth factor goes in there, but if you use your annual growth factor, make sure that you go to the power of exactly a year every time. In this case is X. If you used Y, it would be understandable, right? Years. Or if you use that original growth factor that you calculated over the 6-year period, just make sure that you're taking your years in the exponent and dividing it by 6. Again, I'm not sure why I didn't include those context questions on the review slide, but either way, I'll add it now. So what does F5 mean in the context of this problem? Well, since the value we're talking about now is years, so this would be the value of the car in 2021, aka 5 years after purchase. What would that value be if you actually plugged it in? It would be 11,624. And that number makes sense because it's pretty close. It's 1 year away from being what it'll be worth in 2022, $10,000. Okay. All right. Let's get it. I'm realizing at least the review I'm looking at in front of me right now has a different problem here where it actually says, so I'm just going to change this to what I think you're looking at, which would be 3 times 10 to the power of x equals 1,500. Yep. So solving for x here, we're going to use our logarithms and a couple more things. I guess I have to change these slides next year, make them match up. Divide each side by 3. That'll get rid of the 3 you're looking at. And then you've got 10 to the power of x equals 500. Okay, nothing fancy yet. But now we're going to have to get where we are using logarithms. And if we have base 10, we don't really need a base. If you don't write a base, that's like saying base 10. So we're saying log base 10, 500 equals x. Okay, and this is a nice one because you can just use your calculator to give you the logarithm of 500 because the calculator button for log assumes a base of 10. Now, if you're using your base 10 calculation, you can just do log 500 divided by log 10. You get the same answer either way, which would be 2.7. So x equals 2.7. If you would have just put log 500 into the calculator, you would have got the same thing because log 10 is just 1. Okay. All right, this one actually matches. Yay, good for us. All right, so our base here is 4.5. 4.5 to the power of what is going to give us 300? That's essentially what we're asking here. Now, if you use this log base formula, If you have the calculator that has the log function, yes, you can just put that in there, make sure the base is correct. But if you are working with a more basic one, you can just do log 300 divided by log 4.5. That's going to give you 3.79. So x equals 3.79. Log what goes downstairs and read a neighbor's dog. It's good for a snack. It's on your back. It's log, log, log. We're done with log. So, okay, we're moving on to this one. This one, Algebra 2 block students. You can ignore this one. Fast forward the video till you get to the next one. But everybody else, make sure that you are following along. How tall is the Ferris wheel? Well, we're going to take our midpoint, which is 50, add it with our amplitude, 40, and we get 90 feet. That's plenty of explanation for me, but if you put middle plus amplitude equals the top height, if you want to explain it to yourself as well, right? So we're 90 feet in the air. How long does it take to complete one full rotation of the Ferris wheel? Okay, so what's the period that we're working with, right? So remember, got to think about our original period with the unit circle, which is 2 pi, and divide it by this little doodad right here, 2 pi divided by pi over 9. And that's a really funky thing to look at. So you might just want to write it as 2 pi. Keep change flip. All right, keep the 2 pi. Change division to multiplication, and then flip the fraction to 9 over pi. So 2 times 9 is 18. 18 pi. 1 times pi is pi. 18. The pi's cross off. We have 18. What did the problem say that we're measuring our time in? We're measuring it in minutes. So we can say 18 minutes. Be specific there. And try to spell minutes correctly, unless you're Mr. Cunningham. Okay, so we need to label these axes here. So we've got our x-axis. This is where we're measuring time. We're measuring time in minutes. Okay. The y-axis is where you're measuring height. Right. And we're measuring height in feet. All right. I'm going to use, this is a funky looking graph because a lot of people look at that as the middle. I'm just going to use that as the bottom. I'm saying that's the bottom of the Ferris wheel. So I'm going to start that at 0. I'm counting by 20s because I got to get all the way up to 90, 80, and 100. Okay, we have a negative cosine graph. Oh, sorry, I should label the times here too. So 2, 3, 4. Let's cut those in half. All right, let me see if I can move this bar. Yes, I can. Okay, you guys can't see it, but I had to move a bar. That's why I was writing all small there. But that'll be fine. Okay, so the reason I'm thinking about quarters is because I know that like in the unit circle, it goes pi over 2, then pi, then 3 pi over 2, then 2 pi. That's the entire thing, right? Well, in this case, that 2 pi is actually 18 minutes. So if this entire if I'm breaking this into quarters, I know that one wavelength is going to take 18 minutes, which means half of that is going to be 9 minutes. Cut that in half, and you've got 4.5 minutes. So that's why it should go 4.5, 9, 13.5, 18. And again, we're doing 2 full cycles. So and then 1, 2, 3, 4, right here would have 36. 27 in between there, 31 and a half, and 22.5. Okay, so cosine wave, it's a Drake wave, right? Negative cosine, because it is the opposite of cosine. Cosine usually starts at the bottom, usually starts at the top and goes to the bottom. Negative cosine is going to do the opposite, which means it does what Drake does, starts at the bottom, then way up. All right, the bottom here, 50 minus 40. So the bottom is 10 feet. Okay. And after 18 minutes, it will be back to the bottom. Now, why did I fast forward all the way to the end? For me, that just makes this a little easier because I know if I go from the beginning all the way to the end, now all I have to do is cut that in half, and that's when I'm going to go from the bottom to the top, which is 90 feet. So at 4.5, again, I'm just cutting these halves in half. At 4.5, that's when I'm going to be up at the middle, which is 50. So I'll go from the bottom to the middle in 4.5 minutes, and then the middle to the top in 4.5 minutes, the middle back down, or sorry, the top back down to the middle in the next 4.5 minutes, and then to the bottom. And then that's all going to happen over again. All right. And then when I want to know when the passenger is 80 feet above the ground in 2 full rotations, okay, well, if we get another color for this. If I go to 80 feet, let's be exact with our points here, right? So I'm between 4.5 and 9. Don't write between 4.5 and 9. I'm closer to 9. I'm not quite at 8. I'm going to say approximately 7 minutes. Keep going. And I've got that at about 12-ish. And then if you think, okay, well, 7 minutes plus 18, right? The full period is 25. And it looks like I'm at about 25 the next time I hit that spot. So 25 and then about 30 minutes, which again would be 18 plus 12. So not only does it visually look like it mathematically with that period makes sense. All right. Onward. Okay. So we got this scenario here with the basketball player. What we're talking about in this first problem is just going 2 feet higher. If we want to add 2 feet to this for g of x, well, g of x just needs to have everything the same. Oh, that's a weird parentheses. Everything the same with the vertex and the rate and all that good stuff. We just need to add 2 to the height. So add 2 to 10, which would be 12. Cool. All right, next here, if I'm describing what is happening that's different in these two equations, I would say that let's look at kind of what's the same here. We both start at 0. The vertex is at the same spot and they both end. What's different is I have 6 compared to 3, 10 compared to 5, right? 5 and 3 are both half of the height of 6 and 10, right? So what's happening here, what's different is the second graph the second graph is vertically compressed by a factor of 1/2, right? So like if you weren't sure at first, like you can do 10 divided by 5. It gives me 2. Well, what's the inverse of 2, right? Or you could say 5 divided by 10, which simplified is 1/2. So that's probably maybe what we should do if we're looking at our new compared to old, right? Like we said we should do before. So, in real terms, like not just the mathematical terms, so the starting point and the peak, they're happening at the same times, right? Or the distance along the x-axis, but the heights are half every time. So how do we make the height half of what it was? Well, let's start with what we had before. All right, our original equation was negative x minus 2 squared plus 10. We need to take this entire equation and multiply it by our factor, which was 1/2. If you put this as 0.5 times negative x minus 2 squared plus 10, that works also. I don't love it, but it would be correct if you also put negative x minus 2 squared plus 10. You took that entire thing and divided it by 2. I don't love to that. I'd rather multiply by that factor, but it could be correct. Okay. Last one. Again, if you're waiting for those stats, you're going to have to get those on the next video. The regular participants, seniors, my seniors, this is for you because I heard that seniors rock this year. Okay, so let's look at what this is doing right now. Okay, this 0.5, what is that going to do? That's going to make everything that's happening happen half as fast. Okay, so half the speed essentially is going to take. So that means it's going to take twice the time. Okay, so something that previously took or I guess we're talking about lateral distance here, right? So it previously took 2 on the x-axis to happen. Now it's going to take 4 on the x-axis. So some important points, a real important point to point out here is that instead of being at its peak at 2, it's now going to be at its peak at 4. So when it says label some important points, 4, 10 would be an important point. Okay. Instead of hitting the ground after 5.162 seconds, it's going to take twice as long to do that. Okay. So all the way over at what was it exactly? 10.3240. Okay. Now, there's a couple points that you can get so that your parabola doesn't look, like you're just drawing a straight line from there. Right? Let's look here. Right here, we are at 4, 6, which means a corresponding point would be the same height, but twice the time. So 8, 6. And again, another point that's, right on here, which is 3, 9. We double the 3, we'd be at 6, same height. So now we can look at our parabola and we can see, hey, the same thing is happening. It's just taking twice as long to happen. Okay, that's the second half of the parabola. The corresponding points on the other end, right? So just like right here, how you have 1, 9, well, double it, going to be at 2, 9. I know it's getting a little crowded in there. Okay. And then 0, double 0. Well, you're not going to double 0, right? You just have 0. So you get the same parabola, but it's like twice as well. I shouldn't say the same parabola. It's just that everything, the same peaks, right? The same height of the peak and the same like midpoints. It's just taking twice as long for everything to happen. So let me just kind of put into words like instead of peaking after 2 seconds, right? It takes 4 seconds. Instead of landing at 5.62, it lands 10.324. So these are different things. So instead of being 9 feet off the ground at uh when was it 9 feet off the ground? 9 feet off the ground at, sorry, I lost my train of thought there. At 3, right? 3, 9. We double that to 6 and 9 stays the same here. That's where we get these corresponding points. All right. And the next, that is the last problem. So good luck on your exam, seniors, and everybody else. Look forward to the stats part.